Semiconductors and LED definitions. Semiconductor, it is a solid whose electrical conductivity is controlled by adding other elements. Semiconductor is the electrical resistance between the conductors and insulators, and an external electric field can change the degree of semiconductor resistance. Devices and equipment that are manufactured semiconductive materials are the basis of modern electronics, which include radio, computer, telephone, television, and many other devices. Semiconductor electronic parts include transistor, solar cells, diodes, light-emitting diodes, and analog and digital integrated circuits. In these figures, we will show semiconductor electronic parts: transistor, solar cells, diodes, light-emitting diodes, analog and digital integrated circuit. Types of semiconductor. Semiconductors can be classified as intersonic semiconductor, extrasonic semiconductor. Extrasonic semiconductors are further classified as N-type semiconductors and B-type semiconductors. These two types are shown in figures. After knowing the definition of semiconductor, we will talk about light-emitting diode LED. LED is a light source made of semiconductor materials that emits light when an electric current passes through it. How LEDs work? LEDs are simply diodes that are designed to give off light. When a diode is forward biased so that electrons and holes are zipping back and forth across the junction, they are constantly combining and weaving one another out. Sooner or later, after an electron moves from the N-type into the P-type silicon, it will combine with a hole and disappear. That makes an atom complete and more stable, and it gives off a little burst of energy in the form of a tiny packet or photon of light. This diagram summarizes what happens. N-type silicon, which is red, has extra electrons, which is black. P-type silicon, which is blue, has extra holes, which is white. Battery connected across the p-n junction makes the diode forward biased, pushing electrons from the N-type to the P-type and pushing holes in the opposite direction. Electrons and holes cross the junction and combine. Photons, particles of light, are given off as the electrons and holes recombine. Types of LEDs. LEDs are specifically designed so they make light of a certain wavelength, and they are built into rounded plastic bulbs to make this light brighter and more concentrated. Red LEDs produce light with a wavelength of about 630 to 630 nanometers, which happens to look red when we see it, while blue LEDs produce light with shorter wavelengths of about 430 to 500 nanometers, which we see as blue. You can also get LEDs that make invisible infrared light, which is useful in things like magic eye. Beams that trigger photoelectric cells in things like optical smoke detectors and intruder alarms. Semiconductors, lasers, work in a similar way to LEDs, but make purer and more precise beams of light. LED parts. In this figure, we will show LED parts: epoxy lens, wire bond, semiconductor chip, epoxy case, reflected cup, LED frame, flat spot, anode LED, and cathode LED. Uses of the LED: visual signals where light goes or less directly from the source to the human eye to convey a message or meaning. Illumination where light is reflected from objects to give visual response of these objects, measuring and interacting with processes involving new human vision. Narrowband light sensors where lights operate in a reverse bias mode and respond to incident light instead of emitting light. Some applications of LED: traffic light, digital LED, stoplight in cars. Some LED advantages: they are tiny and relatively inexpensive. They are easy to control electronically. They last virtually forever. That makes them brilliant for traffic signals. They make light electronically without getting hot, and that means they save lots of energy. At the end of the video, I will thank you for listening to me, and goodbye.